Hey everybody, welcome. Tonight is the 19th of March, Dallas Personal Robotics Night Virtual, and we'll do the usual, go around the table and share our accomplishments and questions and generally robot-related banter. We have one updated slide to share, so this is a good time for a screenshot if you want. All in one place, we have our planned hybrid meetings up through the end of August. These are all at the Dallas Makerspace. Of course, we have the competition coming up with a practice session in May and then a competition in June. And then we have our regular monthly meetings. We've moved now to the fourth Saturday of the month as the default. And as the default, we're also in the North Lobby classroom. That's the new room since the Makerspace expanded. And then this Saturday, we have kind of special presenter reached out and contacted us, and Paul's been working with them. So we're looking forward to a pretty interesting looking presentation. Maybe Paul has more later on. And anyhow, then after that, we have the regular show and tell and run in person that we'll start after that. Anything else we should put on the calendar before we start the session?
I've got a few updates, DPRG-centric updates that I'd like to bring to the group here.
Okay, so I'll stop presenting.
So thanks for the list of upcoming dates. I want to encourage everyone to attend either in person if you can or virtually at this week's on Saturday's presentation by Kabam Robotics, and I put together a little video that I sent out. Are you all seeing this YouTube video?
Yeah.
So this was I just excerpted a few things from Kabam's website, but Kabam is a Singaporean company that manufactures two security robots, and their VP in the US is going to come and talk to us about the robots on Saturday. So please come to the meeting and or dial in. He'll also be inviting us to come and visit their experience center in Irving. So this is their indoor robot. So we'll be talking about setting up a date for that while he's there. There will be pizza at lunchtime on Saturday. So anyway, it should be a really interesting presentation, and they're expanding their I think I love this one, the smoking detector, and there are some interesting things they bring up, like unattended object. Okay, what is the definition of that? So I think we can ask him some real interesting questions, and this group, I'm sure, will have some thoughtful questions to ask. So that's one thing. A second thing is I would like to encourage any of you that do Facebook to follow DPRG Dallas Personal Robotics Group on Facebook, and when you see posts come out, if you wouldn't mind liking them. I'm trying to build that as a channel, and trying to put a couple of posts a week up. Just low volume, but something to try and organically build it as a way to reach out and reach more people who would be interested in the things that we're interested in. And the last thing is we are. So some things have been happening in the club in the background since the last members meeting, and I want to provide a short update on that. One of the requests at the last members meeting was to do something that would enable members to communicate with one another in a more friction-free way. And so we've had a comms team off working hard on that. And what we've decided to do, and we presented to the board, and the board agreed with the recommendations, that we switch our mail server from the current mailman mail server at dprg.org to a Google group. So we'll be, once we get the policies figured out and decide how that's all how we're gonna add people and rules on joining, etc. We'll be rolling that out as an email vehicle. And then the other thing is we've decided to start a Discord server, a DPRG-centric Discord server. So this is a different, but sort of side-by-side to the personal robotics Discord server, not in place of, but as well as to try and facilitate communication between members. So you'll be seeing news rolling out on that. So if any of you aren't on the current DPRG list, I'll probably be reaching out to you specifically as we go through the rollout. So that's the DPRG news. Are there any questions related to any of that? If not,
the mail server, how are you going to know it's changed, or is it just going to be a different URL or a different address?
So we will certainly advertise through all our channels, including the mail server itself, and then I've been copying people members who I know weren't receiving emails from the DPRG list. So we'll reach out in every way that we can, including this forum. And we have yet to figure out some things like how do we handle backward compatibility? What if someone posts to DPRG list? What happens then? So there's still a number of TBDs to be worked through, and that's why we're not rolling it out yet. So this is pre-publicity, as well as soliciting any input, questions that that the comms team maybe wants to think about and consider. Anything else?
Paul, I was busy making notes and typing. Did you mention how to join the Discord server?
It's not open for business yet because we haven't.
Okay.
We haven't settled on the policies.
I see. Okay. So there will be an invite or broadcast when that's available.
Yeah.
Okay.
There are a few of us trialing it at the moment, and it seems pretty good to me. I'm certainly getting some value from the interactive feedback. Yeah, so we're trying to make communications between club members easier. Okay, with that, are you ready, Mike?
We'll find out. You know how demos go.
Okay, you got it.
All right. So, you can pin this the screen with the cans in the course. I made a course out of cardboard, and it's a little shorter than the competition course because it's just not. I just don't have enough room, but it's just as wide, so that's good. And so I'm just gonna let it run, and I'm going to put up I'm going to share the RViz. RViz is a tool in ROS and it displays what the software sees, basically. So basically, it's going to show what the software sees, and you get to see what the physical sees. So let me try to locate it here. I'm going to try to grab just the RViz screen.
Well, this is exciting. Real live demos. I love it.
Yeah. So can you see the screen?
Yeah.
Okay. So so on this screen, I don't know if you can. Oh, I can go to RViz. Okay. And I think you can see my mouse.
Yep.
Okay. So this is the course, a shortened version. It's 7.5 feet long instead of 10. And right now the robot is here. You can see it on the other screen. It's basically at the start. And I'm using my time of flight sensors to mark what it can see on the walls. And I had to do some adjusting on the time of flight sensors to calibrating, and because they had a curve to them, and I found a formula using a sine function to correct the curve. So somehow in these time of flight sensors, depending on the angle of the sensor, because it's an 8x8 sensor, there's a single sensor it seems like, but there's 8x8 places on it, and depending, and they point in different directions, and well, they detect in different directions, should I say, and it seemed like when it was straight ahead, it had more of a distance, which was an error, and then when it went to the sides, it had a distance. So I had to correct that curve, and now you can see that the lines are pretty well straight. And if I go over here and move the robot a little bit, you can see it shows on the screen the difference. If I put it back to where it should be, and there's some functionality in robotics called SLAM. I don't exactly know what that stands for. But what it tries to do is it shows this is the black outline here is the walls, so it's a map, and then this is what the robot sees as where the walls are, and when it sees a mismatch, it'll reposition software-wise where the robot should be because during the operation, the robot its odometry will drift, and so it'll start to go a little crazy. And so I'm just gonna get the thing running here.
Before you kick it off, Mike, a question. Yeah. You've got 3 8x8 TOF time of flight sensors, and I see there are 8 dots on the left and presumably 8 on the right, and then there seems to be a largish gap before you see the presumably 8 dots from the front sensor. Is there a gap in the field of view that's showing?
Yes. So when I designed my sensor array, I used 3 of them, and I mistakenly thought they were 60 degrees. And then I was getting weird results, and so I reread the data sheet. And when I reread the data sheet, it was 60 degrees diagonally. So it's 45 degrees, and so they're still pointing as if they're 60 degrees. So it has a blind zone to it. So
thank you.
That's why there's a gap. Yeah.
Are you finding that if your sensors at a very shallow angle to like a sidewall that you don't get any readings off of it just because it's so shallow?
It struggles, yeah. Like you can see these dots here, they're intermittent.
Oh, in the middle?
Right, because they're like the dot here is basically at a 90 degree, or straight on from the side sensor, basically. The wall is perpendicular to the sensor, and then over here, it's at a 45 degree angle or so. So that's why these dots here are doing this, and also it's picking up some of the cans on the thing. I used a sensor that was further up from the bottom, and it sort of sees over the cans. But if I went up a little higher, then it wouldn't. It was a little less sensitive to the walls because it would be looking over the walls. So this is the sensor. This is like the fourth one, which is basically almost the middle of the sensor. So it's pointing straight out. Okay, I'm gonna get it going. Uh-oh. The demo is not working. Oh, hold on a second. When I see this, I have to do something, which is something that I haven't figured out how to fix. It seems like the OpenMV camera, when it's spitting out messages on the serial port, if I'm not connected to it all the time, it's like the serial port overflows, and I have no way. I don't know how to control it, so I just recycle the power on it. See if that fixes it.
Yeah. You can do a loop and like read it very often so that you don't overflow your buffer.
Yeah, but if my software is not operating, it doesn't read it.
Oh, it doesn't read it. Oh, okay. Yeah.
Right. So I stopped the software, reset it. Let's see if I magically work again.
Or if you start up, you can clear out the buffer and basically use the latest whatever message you're sending across your serial port.
Yeah, I gotta try to sort of figure that out.
Yeah,
I'm thinking almost of using the serial pins on.
So for those that aren't familiar, what we're watching here is basically Mike's robot practicing a DPRG contest called 6-can. And the arena is a defined space for the arena, and we have a handful of aluminum cans coated with orange duct tape, and the goal is that you push the button, the robot has to itself find the cans and take them to the goal. And as this was a live demo, this is a gold star, am I right?
Gold star!
Gold star!
Gold star for Mike, yay!
Is Mike frozen up for anybody else?
It looks like he's frozen, but we're still envious that he was able to get something running and the rest of us are just watching.
Oh, he's left.
I think he's going to rejoin here momentarily.
Yep.
Do you mind me asking to restate the competition? I heard can, like a soda can, Charlie Alpha November 6. Is that correct?
That's correct. I'll see if I can find the rules and paste them into the Slack.
Good man. Thank you.
But it's basically a soda, a pop can, soda can, whatever state you're from and whatever you call it.
Pop if you're from Ohio, right?
Yeah.
Oh, there goes the robot. It's dropping a can off.
Thank you, Mike.
Oh, it's cleared 4 of them. Just going back for the rest.
If only we could rewind Google Meet.
Yeah.
Yeah, his video froze. His robot didn't.
Right.
Look at how graceful that claw is.
Yeah.
Scott Gibson, you might be trembling in your shoes. Is that true?
No. I still got him beat on time.
Okay. Well, how do you know he's just not playing you by running it really slow?
You know, that I don't know. It's really Ray that should be worried about his second place. Because, yeah, that looks nice. I mean, that's some good work, Mike. I mean, very graceful.
Serious style points. And this was Ross too, right? Is this one of our first Ross robots to do this competition?
Yeah.
Yep, I think it is.
That's worth another star of some kind of that's Blazing Trails.
Right. The black star for technical achievement.
All right.
And no Dockers.
I don't know if that would be true, Ray. We'll have to ask him.
Yeah, I thought he was running it, whatever, natively or without any Dockers.
I think he's using a Raspberry Pi, so that would... he might have Ubuntu. Yeah, that's right. He's got Ubuntu on his Raspberry Pi. I forgot about that.
Yep.
And Mike, if you're trying to talk, you might be muted.
Scott, did you see that speed surge? You might be in trouble.
It was going towards the wall, though.
He's just psyching you out, Scott.
I think he's sandbagging for sure.
This is the hustle.
I wonder if it's searching for cans when there are none.
I think it's panicking. It doesn't see a can in there. Yeah.
This is the psychological ops part of the competition.
Mike, if you're talking, you're muted.
Still muted, Mike.
Is that better?
Oh, yeah.
Yeah.
Oh, I was talking away.
Oh.
If only we had a rewind.
Could you give us the Cliff Notes version? No.
That was excellent. Really excellent.
I wonder why no one was speaking because I was talking. So let me
Gold star.
let me go back to what I was trying to show and talk about it. I didn't notice that I was muted. Okay, so I'm sharing the RViz again, and so when I back up, you'll notice that I'm going to back up across here, and you notice that these pixels pull away from the wall, and when I stop, they go back to the wall.
Ooh.
So,
Ooh.
Unless your video freezes.
Oh.
How'd the bot go through the wall? Froze up again, aren't we?
Yeah.
I wonder if No, that can't be it. It's faster than that.
I think he's using odometry for localization, isn't he?
I don't know.
And odometry and maybe compass, but that would explain, if the wheel slipped or turned faster, that would explain why it's now outside the arena.
It could be he just hadn't updated his position from his sensors.
It seemed like his feed dropped out when he tried to show both the camera and Arvis.
Yeah.
Mike, it seems like the feed drops out when you show both Arvis and your camera, and right now your camera is muted. There you go.
Okay, so this other one lost connection. Okay, so I'll just be on this one now. So. All right, so that's sort of my what I was working on with the time of flight sensors, which I said I'm pretty pleased with them, except during movement. I was really pleased with them. But I do have a question for Ray, because he mentioned months ago that he cycled between different blob calibrations.
Yeah.
Because depending on the shadows and the lighting and stuff, it doesn't always work. And so did you do that in the camera itself and just did it continuously and then picked the one that you thought was best and sent it to the software? Or?
No, basically I had an array of the I want to say it was LAV selections for different lighting conditions, because like in the outdoor contest you can be in full sun to a shadow under a tree or something. And it would, if it didn't see anything at that, they don't really call them signatures in the OpenMV, but if it didn't see anything in that range, it would jump to the next range and see if it could find a blob in that range. So there were I think either 5 or 6 of them that it would just cycle through.
Okay.
Until it found
I was thinking it would cycle through and just pick the best one, but it's sort of the same algorithm. Yeah.
Yeah. Whatever color combinations, the camera saw. So, and it would. So yeah, if it didn't see any blobs in the ones for lower light, it would go to the ones with, higher light intensity, and usually would find those.
Because I noticed even in the room here, the daylight through the windows change, and it's enough just to make it flakier, and then I turn on some of the lights in the room and some of the other lights in the room, and eventually it starts working again.
Yep.
So I was thinking I got to take care of that. Huh?
Yeah, even if you just did on PixieCam, you did signatures facing one way versus facing the other way. The two sides of the cone could have very different lighting conditions, and
right.
It's so specific that it just it doesn't say that's about right. It's either in or out, and
because I found one that was pretty wide, but it's just not wide enough. But like you said, I probably need 4 or 5 different ones and cycle through them.
Yeah, that's what.
I'm not going to do outdoor, but the shadow stuff. Yeah.
Yeah.
And Mike, are you using odometry for navigation?
Yeah, I'm using the wheel encoders, and I haven't enabled the IMU yet. So that's another thing I'm going to do is try to enable the IMU and see if it maintains its odometry a little better. But so now I have this display that shows the slippage with a graph. And so I can sort of go, okay, go through its motions. I think I'll have it go between a lot of different waypoints and then just see how badly it distorts. And then turn the IMU on and see if I can make it distort less badly.
And do you have a compass to give you heading?
Well, it's in the IMU, but
oh, okay. Sure. So it's not turned on. You're using just the wheel encoders for orientation currently.
I'm only using wheel encoders right now.
Wow.
And so I'm going to enable the Kalman filter in ROS and add in the IMU and see if I get better results.
The one thing I would recommend is at some point, because even with an IMU, the odometry tends to drift. Any kind of slippage, especially when you're rotating, that seems to create, a little bit of error in your angle will really, 2 feet away, it can add up to a big error. So at some point you want to kind of periodically reset yourself or look at where you're at, right? And you can do that with your time of flight sensors, maybe trying to orient to a wall. I know I've tried like aligning to one of the sidewalls before. I think, Ray, you've done that too. Or basically lined on the edges of the goal. So that would be something you might want to look at implementing as well, is being able to reset your odometry at some point.
I don't know if you saw the demonstration where I have the odometry displaying on a map and showing that it's showing the distortion. I can. Whoops. Okay. Turn.
You're muted. You're muted, Mike.
Okay. Yeah, both machines are muted, so now it's good. So I'm gonna share it one more time for Scott, because I think this is what Scott's recommending, or at least. Yeah. So if I bring my robot back to its starting point, and then realign it, you can see that my time of flight sensors, they're the white pixels, the white dots, and the black is the outline of the course walls. And so the time of flight sensors see the course walls, and then in this opening it sees stuff behind it, and so it so when it moves around, looks like it started off a little crooked, and so this is called SLAM in, I guess, robotics and ROS, and so somehow they got a really great algorithm that can match this with the wall, and it can figure out what the offset, the odometry slippage has been. And so I'm anticipating being able to do that to correct for.
Yep. It's always a good practice to, not just rely on odometry, but have something to back that up with, or to reorient yourself with. And it looks like you've got the data to be able to do that.
Yeah, that's frozen.
I think Mike froze again. Seems like every time he gets Abby's going, a little while later, his feed freezes.
Should have gone for the i9 or based laptop. That i3 isn't cutting it anymore.
Or Google. I find these browser scraper things they just trash your system. I have these 4K monitors beside me, and I have to bring them down to 1080p, or else I can't do this.
Oh wow!
With a 4-year-old i7 and plenty of RAM. Mike, you're back, but you're muted again.
You're muted.
Still muted, Mike.
Maybe I'm overloading it with two machines, so I'm going to turn one off. So that's the extent of my show and tell.
Awesome.
Sorry about dropping out and wasting your time.
No. It's awesome to see. I mean, you're doing great.
Yeah, I'm not using the navigation stack yet. Like the column filter is not part of the navigation stack. I'm using the transformation packages and stuff like that, and the messaging packages, but I'm not using the navigation stack. I think in ROS 2 it's called something new. I can't remember, the navigator or whatever it is. But good old ROS 1 parlance is the navigation stack. I want to be able to use it, but I'm just doing this on my own. It's my DIY navigator.
All right. I think John was next up.
Sure. So I've been doing a bit more work on this guy, my universal robot configurer smartwatch wearable thing. So one of the things that occurred to me that I want to be able to do when I'm running a Robo-Magellan robot is if I'm sitting, if I'm doing practicing, I'm not running the competition here, but if I'm out in a park or something and practicing, one of the things you want to do is you want to be able to just set an arbitrary waypoint, and say, go over there. And that's kind of difficult. You could drag the robot, 500 yards over that way and put it down and use the GPS and then bring it back again and then have it do that. And that seems kind of silly. So what you really want to do is you want to have a Google Maps display where you can do that. And of course, this thing is way too small to run Google Maps. Not going to happen. But this, on the other hand, can run Google Maps just fine. So it turns out that Google has a nice JavaScript API. I hesitate to say nice and JavaScript in the same sentence, but it has a JavaScript API, and you can serve up a little tiny HTML page that shows a Google Maps screen on a website that you can then do things with. And of course, it's not Google Maps that's in control. It's kind of your code that's running that's in control. So I've been experimenting. And of course, since this has an ESP32 in it, I can put that in access point mode so that this thing becomes effectively a web server. And I can open up a web browser on my phone and, connect Wi-Fi to this, and then I can serve up that page from this device on my phone. And so bring up a map with Google Maps, and it looks something like this, although this isn't in, let me switch it to satellite mode. So that's in satellite mode now. And you probably can't see it, but there's a little button at the top in the middle that says send waypoint. And the idea being that you can, if you want to zoom right in on a particular field and you can touch somewhere and it gives you the GPS coordinate of where you touched, and then you can push that button and it will send that coordinate to this. And of course, this can talk to the robot using ESP Now, and then send that coordinate directly to the robot, and then
you lost audio, John.
Sorry, must have clicked on something. Did I lose audio for long, or
no? Just a few seconds, but you're back now.
Yeah. So so you send that GPS waypoint to the robot, and then you can just start a simple mission that goes there and comes back or whatever. And with the idea that I don't want to drag a laptop around with me. What I really only want to have is this, but I can't do Google Maps on this, but I'm going to have this in my pocket anyway. So I might as well take advantage of it. And so the other thing that I did is I added a new kind. This is of course, this thing's running a full GUI that I've implemented. And I implemented a new kind of widget that allows you to basically just draw on the screen whatever you want. You've got however many pixels there are, and you can draw on it, you can touch it and interact with it and stuff. And so this is a set of GPS waypoints lifted from that park that I just showed you. They're in a JSON file in the file system of this thing. And so it basically takes those GPS coordinates, it converts them to local coordinates, with the origin being, you can see the two grid lines there that are a little thicker, horizontal and vertical. Those are, that's the 0, point. Each of those lines is 100 meters. To give you an idea of the scale, and it auto scales the whole thing so that it fits on the screen. And screensaver kicks in, and so you can use that to choose what I call cone sets, and this is for when you're actually running a competition or something like that. So when you get to a Robo Magellan competition, you have a start cone, or a start location at least. You've got one or more bonus cones, and you've got a finish cone. And you get 3 runs. And so the first run, you might just want to run straight to the finish cone, and not bother with any of the bonus cones, just to get sort of your time on the board. And then you may want, in the second run, well, I'll hit bonus cone 2 first, and then I'll go over to bonus cone 1, and then I'll go that. And so the idea here, and you might have a whole set of waypoints that you set up beforehand on your laptop, with a proper interface and stuff. So you would have a set of waypoints that go from the start cone to bonus cone 1, and you'd have a set that goes from the start cone to bonus cone 2, and a set that goes from the start cone to bonus cone 3, if there is such a thing, and then another one from the start cone to the finish cone. And then you'd have the same thing for each of the cones. You'd have a set of waypoints. And so I call those things cone sets. And the basic idea is you can choose your path that you want the robot to follow by picking which cone sets in which order you're going to run. And so this thing, the concept is each one of these little dots, and they actually have a letter in the middle, which is the first letter of the cone. You can't really see it because the screen's kind of washed out, but the one at the origin says S, and then there's 1, 2, 3, and F for finish. And so you choose these things in order. So I want to go start, and then bonus cone 2, and then bonus cone 1, and then finish. And then you flip back to, you just go back to your mission run screen, and, that gets sent to the robot, and that's the mission it's going to run right now, kind of thing. So it allows you to configure those things really easily without having to sit there on your laptop and deal with all that crap. So that's one of the things that I'm working on with this.
Awesome. Can you explain again you got a web server on the phone that works with.
Okay, so no, there's a web server. There's a web server running on this. Okay, so this is all running MicroPython on this, and there's a web server available on MicroPython called Microdot. It's basically very similar to Flask, apparently, and it is a very small thing, but you can serve up web pages, you can do gets and posts and things like that. And so the idea is that I connect my phone to the device over Wi-Fi, because I set this up as a Wi-Fi access point. And so I just connect to it. It shows up in the Wi-Fi list on my phone, and I connect to it. And then I go to a particular URL on a particular port, and I'm seeing the web page that this device is feeding to my phone, just like a normal web server does. And so that web page that I'm going to go to is going to serve up a Google Maps API, which runs on the phone. And then you can choose a waypoint from that. And eventually I'll probably set it up so you can choose a whole string of waypoints and then send those to this device by pushing that button at the top of the screen. And then this guy now has basically a JSON file that has a list of GPS waypoints. And then you can use those how you like.
Okay, so when you had an internet connection, that's when you captured a static map for your Google map. Is that true? Or?
No, it's live. But I have to figure that out, actually, because one of the things, like when I connect to this guy obviously doesn't have any internet, and the phone does. So I'm not
You lost audio again.
Sorry, I keep hitting the space bar, and the space bar is the last thing I clicked on, which of course is the mute button. So I have to test that, because I haven't actually tried it on the phone if I'm connected to a Wi-Fi source, but I also have, data, and I don't know if it can do that split. If it can't, then I have an alternative that I can do, which is I have my own web server running in the cloud that I can serve up those pages to. I can gather the data that I want, click, send it, and then connect to this thing and send that file to the device that way.
It almost seems like you could use the phone as a hotspot and use the data connection for your internet.
Actually, that's not a bad idea. Yeah, that might actually even be easier. I like that. Yeah, because then the phone can effectively provide internet to this guy, mm-hmm. and he will effectively do that. Yeah, that's a very interesting idea. I'll have to think about that. I'm not sure exactly how that's all going to work in with the Google Maps JavaScript API and all that stuff, but we'll see. I mean, if I wanted to do a static map idea, I could do that, but then I'd have to write an Android app, and I'm really trying to avoid writing Android apps because that really sucks. The reason I like programming on this is because it's MicroPython and it's really simple, and there's no overhead. There's no operating system. There's nothing. You're running on the metal and interfacing directly with the display driver and the touch driver. So. But anyway, this stuff's all going to get open sourced. I put a first version of the code up a couple weeks ago in my GitHub. It doesn't have all of this stuff in it, but it's got a lot of it. So I'm still experimenting with all of this stuff to see how it will all work out. But I've got a bunch of time. I'm working on the RoboMagellan robot sort of in parallel, but it's not going to be ready for another month or two to go outside and start running. So it would be nice if I had something where I can actually test it and run it as soon as it's ready, kind of thing.
Yeah. Well,
and for anybody who hasn't seen, let me grab here just a second. Sorry, I'm going to grab, trying to find the right browser tab here. Google Photos. Here's a good picture of it. So let me share this guy. So that's what my RoboMagellan robot looks like right now. It's basically a 1/10 scale hobby grade radio control rock crawler that I've converted into a robot. It has it's full-time 4-wheel drive. It's got a censored brushless motor, high quality servo, digital servo. It's got a Raspberry Pi 4 underneath this 3D printed case here. It's got an Oak D Lite 3D range finding camera that also does object detection. And I'm working on this embedded board right now, the prototype board here. I've got a bunch of stuff soldered to it. This is the main embedded processor. It's an STM32 F405 running MicroPython. There's also going to be another ESP32, one of the Seed Studio ones on here, which is going to be my fail-safe. This bar up here is a carbon fiber tube. Up at the top of that is my 9-axis IMU, and hanging off the back of that is my GPS and some LiDAR sensors for helping when I'm backing up.
Did you mention what chassis this is? It looks like a pretty beefy chassis.
It's an extremely beefy chassis. This is basically, I don't know if you guys are familiar, but this is effectively an aftermarket axial Capra. But it has aluminum Vanquish axles, which are like machine from a billet aluminum. They're not like cheap stamp whatever Chinese ones. They're ridiculously expensive, but they also are completely bulletproof. So yeah, it's basically all metal chassis. I've done insane things with this off-road as an RC rock crawler. It stands up to everything. So I'm not even remotely concerned about that. And then I basically took off the body and added a bunch of 3D printed parts. And I have more parts to add as well. But
the steering is still the standard Ackerman steering on this one?
Yeah. Yeah. Yeah, it can turn the tires about 45 degrees, so it turns pretty tight. And there's a quadrature encoder attached to the motor's output shaft that'll be feeding into the STM32 over here for doing odometry from that. Yeah.
Is it a 2-wheel steer or a 4-wheel steer?
No, it's 2-wheel steer. 4-wheel steer is actually kind of dangerous in some ways. I mean, it's okay if you're going really slow, but if you're going a little bit faster and you start using the rear steer, it's really easy to flip these things over. I plan on running this. I mean, it's going to be running at different speeds depending on what it's doing and what's in front of it. But it's going to be it can go faster than you can run. But it can also go 1 inch per second if I want. It's got an incredibly wide range, and it's a field-oriented control brushless motor, so it can go really slow or really fast with lots of power.
Yeah, that's what I understand about the brushless motors and those chassis. I know on the donkey cars they tell you to stay away from them because of the poor low speed control. But,
yeah, those are brushless motors that don't have sensors.
Yeah.
This is a censored brushless motor, so I can literally drive this at maybe half an inch a second, and it will climb over your foot at that speed without any problem at all and completely smoothly. it's these things are unbelievable. So yeah, it's and it's a very low slung machine. All the heavy stuff is at the bottom. Metal axles and metal wheels and whatnot, and the motors here and the transmissions in there. It's basically got differentials with drive shafts and a transmission that the motor's hooked up to. And it's got a proper, in the RC rock crawling world, you want a 60-40 weight distribution where the front end has 60% of the weight and the back end has the 40% of the weight. It allows you to climb hills a lot better and stuff. And it's also very low slung. So I can run this along a 45-degree slope sideways and it won't roll over. So yeah, it should make an interesting robot. Oh, and the Raspberry Pi 4 is going to be running Smalltalk, which is my language of choice. We're doing its autonomous control, like its high-level autonomous control software. All the microcontrollers will run MicroPython. Yeah, and the failsafe is done using ESP Now with the this thing has an ESP32 S3 and the robot has an ESP32 S3, so I can do direct peer-to-peer communication over ESP Now with it. And I have a couple of different fail-safe triggers for anybody who hasn't seen them. This thing has there's a little 3-pin plug in the side, and you can take a cable and plug it in. And then I have a couple different ones. I have one that's a ring, which is exceptionally uncomfortable to use. And then I have a handheld trigger, which is just a push button with that. And so when I plug this in and click the run button, you can see up at the top there, the red word, it says paused. And then when I pull the trigger, it says running. So that's the fail-safe. And of course that works either with this or with the ring. It's the same thing, it's just a push button. With the ring, there's a little white push button here, and I can push it the same way to get the same result. And this is obviously, this is a wrist mounted thing, so you can, if you're doing the ring, you can just stick the ring on your finger and use your thumb to control it. So yeah,
very cool. I think a Black Star Award is in order for the technical advancement of hooking up Google Maps to essentially an ESP32. Yeah, lots of fun. So I'm still working on that stuff. I've just started playing with that in the last few days, the Google Maps stuff. But I think next up I'm going to be working on the network, the ESP Now stack that'll run on the device and on the robot, so that you can, and of course this does telemetry as well as control. So in control and configuration. So you configure the robot, tell it what you wanted to do, and then you start it. And of course it's feeding back real-time telemetry on the screen. The screen, it shows all kinds of stuff. Right now on here I've got the GPS, the number of satellites it's got, and how good the fix is, which navigator is in running, which finite state machine is active, the distance and bearing or compass heading to the next waypoint, and your current position, your current heading, the voltage of the robot, the voltage of this thing. So yeah, you can display. I mean, you can display whatever you want on there if you can fit it on the screen. And this is all a windowing framework that I've designed such that other people can build up their own. And I call this my universal robot controller because you can see I have that robot on there, but I also have other robots that I plan to sort of configure with this, including my quad walker robot.
So, you can have an entire set of windows underneath each robot that defined however you like.
Cool.
So I'll do once I get a little further along in the project and have it actually talking to my robot, I'll do a full-blown presentation at one of the meetings.
Oh, I'd like that. Let me know whenever you think that time is going to be, because I'm always on the lookout for speakers and topics.
Yeah, silicon padding on the ring. Well, it's 3D printed, right? Everything is 3D printed. So I'm sure I could print it in TPU. Here I'll just do a quick presentation again for a second. Share, boom. So this is Onshape, which is what I use. I've modified my model. I haven't printed it yet because I'm actually in British Columbia right now visiting my parents' place. I'm not at home, so I don't have access to my printer. But I've added a big flapper to the button so it doesn't hurt as much when you hold it for long periods of time. And that's just going to be pivoting on a pin with the button underneath it. And so this diameter here, I mean, I can generate this, and I basically I can set this. This is just a variable, so I can change this to be, I want it to be 21 millimeters because somebody's going to be using it who's got a really small finger. And so now it's, this inner circle is well, the radius is 10.5, so the diameter is 21 millimeters. And so you can just change this to be whatever you want. And it automatically resizes everything so that it fits. I have big hands, so this one here is actually 23 millimeters, the one that I actually printed, but it's a little bit on the tight side. So I'll try a 24 and see how that works.
Cool.
John's presentation brought up something for the competition in April or June, and that is the 5-corner. How do we get coordinates where the robot's supposed to go in the room?
For 5-can?
For a 5-corner.
5-corner. Sorry, I don't know what that is.
There's a 5-corner where you have 4 corners of the room plus the center of the room, and you're supposed to be able to navigate to those 5 positions, avoiding obstacles and everything.
Yeah. So I mean,
So I'm just saying.
That something you know ahead of time?
That's what I'm asking. Yeah.
Yeah. I mean, this has a USB port, right? You program it in MicroPython, so you connect it to your computer, and it has a file system built into the flash. So you can take like a JSON file and stick whatever you want in it and copy it to this device from your laptop and then read that file when you're running the code, which is how I did that GPS thing where I showed those icons on here. That's literally a JSON file with 5 GPS coordinates, latitude, longitude, in it.
So I guess my question is, when we show up for competition, I guess we go there and then we measure it ourselves and create our own waypoints.
Well, you could. I mean, if it's that kind of competition, if you're going to Robo Columbus or Robo Magellan, then they give you the GPS coordinates of the cones.
Yeah, but I'm talking about the indoor for the.
Yeah, Mike, you're asking a question that I think Carl or Doug needs to answer, because I don't know the answer, because you're alluding to one of the competitions that's on the books for Roborama, right?
Right, Roborama indoor, right?
Indoor, right?
Yeah.
Carl or Doug, do you know?
I'm going to have to go look at the rules. I believe I want to say we give you the coordinates, but to be quite honest, right now we don't even know which room is going to be used. So Well, I guess we do.
Yeah, we do.
It's going to be
for Roborama. The practice is North Lobby, and the competition is interactive.
Okay, gotcha.
They're in different rooms. But yeah,
they're different rooms. Yeah. So, but what I'm saying is, if you can do it in one, you can do it in the other, probably. Well, because the real thing in that contest is not the going to the waypoints. It's navigating around everything that's in the room, because the room is meant to be a completely set up room with chairs and everything, tables, stuff on the floor, everything, and you have to figure out how to get to the corner. You know what I'm saying?
Yeah, it sounds hard. Yeah.
Yeah, well, it can be. We tend to scale these things. Like if everybody says, well, this year we're just starting, this is the first time we're running it, we'll make it easier. Okay. But once somebody nails it, then the level notches up. And I'd have to look at, Mike, if you go to the competition page on the competition tab in the website, there's a sub-tab entry called contest rules. And you look it up there, and you can see, it'll give you the details. Okay, it should be. If you look on our competition webpage, you'll see, this is probably the right way to do it. You'll see the top lead says Roborama 2024, and you just go to that, click on that link, and the rules will be linked somewhere in that post. It's not really a post. I think it's a page, but that's
right. Yeah, it is.
Okay.
Yeah. So I don't know what the intent when it was originally done was, the figure that some people would try to do it with wall following. Okay. But most people would probably do it straight up odometry, trying to get to it, and using some sort of obstacle avoidance to go around all this stuff. So now the problem gets to be, how good is your obstacle avoidance? Because an indoor room, obstacles can be really, really tricky, because they can be any height. And, like you take a typical chair from one of the makerspace and try to drive around it, you can see that there'll be a lot of places where you won't see much signal. Anyway.
Okay. Sounds hard. Yeah.
Well, the approach I used a couple of years ago is kind of what Doug's talking about, where I did, because my robot already has, I call it just a roam feature. It just roams around the room and tries not to run into anything. So my approach then was just to let it roam around the room, and eventually it would hit all the spots until it got hung up on something, which
like
is ultimately what happened.
Yeah,
like it doesn't have to be super sophisticated, right? You can just kind of do it by brute force, I guess you could call it.
Yeah, and just to be clear, this is not intended to control your robot while it's running in any way, other than being a fail-safe trigger for big outdoor robots. This is a configurer that allows you to configure your robot in different ways, and you have to program this in MicroPython for your robot to build the screens that you want and the features that you want in order to be able to configure it. And then, of course, as I said before, you can get telemetry back from the robot to this because ESP now is a peer-to-peer networking communication system. So it runs both directions. It's high speed. The default speed is a megabit. And it works basically like a UART. So you can just send data back and forth however you like.
Yeah, you have to be careful, and I'm sure you are, Jon. But most of those contests, your robot's got to be autonomous. You can't be fudging it, with your watch.
Oh,
Yeah.
Of course not. Yeah, no. This is like that screen that shows the robot telemetry is completely one way. There's no touch other than just exiting that screen, and if you exit that screen, it'll stop the robot because the robot's running on a failsafe. So I mean, once you've configured the robot, you could shut this off if you wanted. It's
yeah.
If you're concerned about that.
No, I'm just saying is, people, you don't want to be, we always take people at face value. If they say they're not doing it, they're not doing it. But, there's a lot of things just simple things like having somebody walk in front of the robot, and the robot can be actually following him. Do you know what I'm trying to say? I mean, there's a lot of things that can be done to cheat, but we got this is a group of fairly honest folk, So we're not going to be calling out people.
In general, the robot is going to have a more powerful processor than this thing is. So
yeah.
Certainly on the Robo Magellan front, that'll be the case.
Yeah.
Do we have any other show and tells? Ray does, and I do. Anyone else? Okay, why didn't you go, Ray?
Try this here. Change some settings. Maybe you could. Can you pin me?
Yeah.
Yep.
Pin. Yeah. Okay. I've put together a platform with these gimbal motors here. And it's got an ESP32 and two DRV 8313s, which are, three-phase brushless motor drivers. And I've got this thing working in a position loop right now. I don't know if I can show the program as well. I guess I'd have to present to do that.
Yeah, you have to present.
Okay.
But we can still have this window pinned.
Okay.
It'll just split it.
Okay.
Okay.
Let's see here. Okay. So I don't know if you can see this. We're doing a program. This one is simple flock closed loop position, which is go away. Anyway, it's kind of tuned. There's like PID values for both angular position and for velocity. So here you can see there's those are the two proportional values for the two motors. Those are the two integral values for velocity. It just uses proportional for angle. And right now both angles are, I don't know if you can see these zeros here. Say that again?
Yes. Yes.
Okay. Anyway, so I can tell them to go to a certain position, but you do it in radians, so it'd be like C 6.28 for a complete revolution. So if you watch the little wheel, hopefully it'll end up where it started. Anyway, and you can...
Can you do that again, Ray? Oh, switching screens.
Oh, okay. I can go back to 0. Let's see, T0. Okay, so it should have gone back. So it's kind of settling on pretty close to 0 for both of them. So if I go to T6.28, that should be a full revolution. And one of the things that I can do is actually twist the motor a little and get it off its set point, and it'll go back to it. So you see the column on the further right, it's going to like 6.2, and if I let go, it bounces back to that position again.
So, Ray, that's a piece of blue tape on the wheel with a black marker on it. Is that what I'm looking at?
Yeah, just a piece of blue tape.
Okay.
Yeah, there's no marker on it. So if I push it, you can see it, resisting my push and trying to come back to that same position. And
okay.
So if you push it a full revolution, will it move a full revolution back?
I've never tried that. I don't know.
They generally get harder to turn as you get farther from the set point.
Yeah, it looks like it will.
Okay, so is this are we looking at the basis of a 6-can Speed Demon robot here?
Yep. One of the other things you can do, like here, this is set up for angle. You can also set it up for velocity and go at a certain speed.
Okay.
So the speed range is pretty good. I think this one actually limits it. Yeah, there's right here a motor velocity limit. It's set to 20. You can actually set it. I've set it as high as 40, and so I've gone to like 35 radians per second, which is pretty fast. That's, I think, equivalent to about a little over 300 revolutions per minute. If you're doing, around 35 radians per second, as far as the velocity goes.
Okay, Ray, is that the wheel you plan to use?
I'm thinking of it.
I can't. Can you bring it up a little closer to the screen so we can see it? Is it what type of wheel is it?
It's just a gimbal motor.
No, not the motor. What is the wheel?
Oh, the wheel. The wheel is an O-ring.
Okay, I thought it was a little strange. That's why I was trying to figure out what was going on. Okay.
Just an O-ring.
Okay.
Well, that's, I don't know, wheel or tire, I guess.
Yeah.
Anyway, yeah, they're kind of, the motor itself is kind of cylindrical, and there's a pretty wide area. I haven't seen anybody, a source to buy wheels. This is actually from a kit from Harbor Freight. You can buy a pretty wide assortment of O-rings. And
Ray, did you see the 3D printed wheel I did for those?
Yeah. Did you make it out of Ninja Flex or some sort of flexible?
No. Well, the wheel itself was white ABS, and then the tire was TPU.
Okay. Yeah.
Hey, Jon, just in case somebody else is interested, can you put the link to the files? Or is that? Oh, excuse me. First, are you sharing those?
Oh yeah. Okay. But I mean, it's for a very specific motor.
I understand.
Which may or may not be that one. Yeah, I'll punch a link out here as soon as I find it.
Okay.
I'll show you a picture of it first, and then.
And switch.
It's a robot I was working on a while ago, but stopped.
So Ray, is that an outrun? What do they call it? An outrunner motor? Is that the motor body we're looking at that spins?
Yeah. It's kind of like this is a hoverboard motor. I've got another outdoor platform that's going to use these. I thought there would be room inside of this for one of the AS 5400 magnetic encoders, but there's no room inside of this thing. I could put it externally. I don't know how that would do in Steve's yard. It may get clogged with dirt and everything else. Who knows what? But this one actually has 30 magnets, so it's 15 pole pairs. So I finally figured out what that meant. And so you have a north and a south pole, and so there's 30 of them, or 15 pairs. And this thing is so strong, I cannot pull it out of this thing. The force that the rotor is kind of, held in there by. So, but, this is supposed to, support like 220 pounds, and you can go like 6.5 miles an hour or so on it, on a hoverboard, if you ever dare to jump on a hoverboard going that fast. So these are the Hall effect sensors, this little printed circuit board here. And there's actually there's 3 Hall effects right there. The little, I don't know if you can see them, the little wires, one there, and one there. And these are the connections for the, for the Hall effect sensors. And these are the 3-phase wires. Whoops. The 3-phase wires. But anyway, so I don't know. I might try to add it external, because if you're using just the Hall effects, it gives out 48 pulses, 96 edges per revolution. So it's not real high resolution. And that's accessible on one of the drivers. The drivers for that are different than the drivers on this small platform. They're like, I don't know if they're referred to as 6-step, but you've got like 6 combinations of A, B, and C windings, and they overlap, so you can basically, it's kind of like in a stepper motor.
Micro-stepping, they call it in the stepper motor world, right?
Yeah. So it's a little cruder. I don't think you can do some of the position control and stuff like that. And there's other ones that actually sense the current in 2 of the windings, and like this one does. And I found out that these actually have what is it? 1, 2, 4 MOSFETs for half bridge, and it'll drive 2 motors, and it's got a socket for an ESP32 on the back. And these will actually measure the current of 2 of the legs of 2 motors. So you can do torque control with that. As far as I know, I cannot do torque control with the DRV 8313s. They don't sense current at all. Well, actually, they have the ability to do it, but these boards don't do it. So they don't use that capability. So,
are you using the Simple Fock Mini board for that, with that driver chip, or some other board?
Yeah, it's a Simple Fock Mini, but
okay.
Yeah. And this board actually has it's 2 channels, basically an op amp. So you can actually like use a very, very small sense resistor and boost the voltage up and translate that as a current. So I found that these are a little touchy if you get the number of pole pairs wrong, or you forget to change it when you're using one motor and another motor that has different pole pairs. It is not forgiving. You can fry it very easily. This one also has a DC to DC converter on it for 5 volts and 3 volts. That's over here. So it's got great integration, but you screw up and it gets fried basically. So like the one of the things that I did on the first one that I had in that program, the voltage motor voltage limit. Oops, I'm not presenting. You're not going to see that. This voltage dot motor limit, you actually start out at 1 volt, and you can go up to whatever your power supply is. But if you do, watch out. I don't recommend it. So, on the other hand, if your motor voltage limit is not high enough, your motor, the motor won't move or keep up with whatever position commands you're giving it, or velocity commands. You can stop it really easy. So it's got to be enough to generate the torque that you want, but not so much that if you screw up, you fry the thing. So
cool.
Anyway.
All right.
So those are kind of neat. I've always wanted to play around with three-phase motors.
Cool, Ray. Thanks.
Sure.
So last week I showed PiDog, and Doug asked if I had tried some of the other programs, which I had not at that time. And so I since have tried, gotten some of the other programs. So if you want to pin me, I'll just do a quick demo of some of its behaviors that I've played with so far. One of the kind of fun ones is 3 patrol. So can you guys see the PiDog?
Mm-hmm.
Yep. So it starts off looking around, patrolling, and measuring distance. And now it's stuck it's meant to be barking. It's trying to bark at the moment, but my speaker's blown. It's sitting there barking at an obstacle. That's kind of fun. And then another kind of fun one is the Superman one.
You guys are going to have to 3D print some dog turds and have a little trap door in the back. He walks up and drops a few, and
So he's got an accelerometer in him, and when you pick him up, he senses that he's being lifted, and so you goes into a Superman pose. And then when you sense that he's being dropped, he goes back into the standing position. So that's kind of fun. I think the push-up just cracks me up.
I don't know if you've seen videos of small dogs. You hold them up over water and they doggy paddle like they're in water. That'd be a neat one.
I like a little kick to his head as he's doing his push-up. And then there's one where he's supposed to do face tracking, and it doesn't seem to work all that well in let's see, in the light at my desk. There's 7.
Oh no!
Oh no! His head fell off.
Durability check.
Damn!
Drop test. Oh no!
Broken servo. Oh!
All right. Well, next week.
Well,
at least the cable's good. Yeah.
Damn. Well, that's disappointing.
Poor guy lost his head.
Decapitated PiDog.
Did you put? Did you forget to put a screw in?
No, it broke the servo when it. Okay, I'm gonna let's see. I'm gonna share my screen to show, because it's got a little web server. Poor PiDog with his decapitated head. I'm going to share.
Well, that camera cable's a Timex. Took a licking and kept on ticking, huh?
Yeah. So, let's see.
Yeah, it looks like it's trying to.
It's trying to track. And so this has got face recognition, and it'll draw a blue box around.
I see it.
Around
yeah,
me.
There you go.
Yeah, that's kind of not very.
I think the problem is you got a big light behind your head.
Yeah, that light may be too bright.
Oh, okay.
Yeah.
Oh, yeah. Well, I don't know. It just doesn't seem.
Yeah, Paul, I don't think on mine it worked a little better than that, but I don't think it's super robust. I think that, that's an opportunity for user to put a little more robust face tracking in it.
Okay.
The object recognition is even worse.
Okay.
But, but it does work, so that means that probably what you really need is one that's trained properly.
Okay.
Where did it break? I can't believe you broke the servo.
Well, it landed on its head, and you can see the gear.
Okay. You
broke the servo right.
You didn't necessarily break the strip the gear or anything. You just
no.
tore it right off.
It exploded.
Yeah. Tore the head off the servo. So there's the two remaining pieces of the servo.
Wow.
So
super glue.
I get another servo size. Doug, you know all about servos.
Well, that's just a standard 9 gram servo. I think you just want the one that says M. Oh, well, for those small ones, it might be SG.
It says SF006FM digital servo.
Yeah.
Looks like it's got metal gears at least.
Well, yeah. You can. I tell you what. You ordered this off Amazon, right?
Yeah.
Go tell Sunfounder, and I bet you they'll send you a replacement.
Yeah.
They were real good about that sort of stuff. So
okay.
Just tell them, where you go to your order and it says, talk to the vendor or something, and just tell them, hey, I broke a servo. How can you guys give me another one?
Yeah. They they need to send me a new robot head anyway because the speaker's broken on this one.
Yeah.
Yeah. But maybe I'll get two things.
Well, the speaker and the servo are broken. you won't be lying. So you tell them both the speaker and the servo are broken.
That's not right. The speaker really was broken. I took it out and ohmed it out, and it's open circuit from when I got it. But, well, you've seen the destruction of poor PiDog.
PiDog. Maybe we can get him one of those collars, for
a collar.
If we had a star for demo effect, we'd give out a lot of stars.
I think it is amazing how many times people try to demo something and it doesn't work. At least not the way they expected it.
It's always something.
Yeah,
I think that's a bronze star.
Yeah.
Nice.
Well, okay, that's all I got. So unless someone else has got a show and tell that they want to bring up, we'll switch to open mic. No?
I thought I heard somebody say earlier they had a question they wanted to ask. Maybe I misheard that.
I think it was Bradley.
Yeah, I was just looking at one of those robots and I saw like a screen that looks familiar, and I think it's running my soldering station right now. Is that your power distribution? You're using like a DROK, I think it is, on Amazon, like power for the one robot that y'all were talking about, the O-ring wheel. And I want to know how the 3D printed wheel worked out for y'all too. Always combining TPU and ABS is a fun experiment, right?
Yeah, I don't know if my my now ancient 3D printer would actually handle, the TPU or not. It might just gum up and.
You'd be surprised, and then you get to rebuild the 3D printer. It seems like a capable crew.
Yeah,
it's a pain in the butt printing TPU.
Yeah, the main thing though, Ray, is just is it a direct drive or is it one of the Bowden tubes?
It's a direct drive.
You should have no problem. There's two places that you have problems. One is if you've got anything set on retraction. Retraction has to be zero. Retraction has to be zero.
Thermal creep at the throat.
Yeah, and then the second thing is the spacing between your gear and where it enters into the hot block. If you've got any gap there at all, it'll be like it's like pushing on a rubber band.
Oh.
You can imagine the impact. So, but if you do it, get those two. You're going to have a lot of stringing because you have no extraction. Okay.
Yep.
So and you're talking about an older printer. That's why I'm, but that's okay. That's the stringing's not that big a deal.
Okay. Yeah, I have to, I guess, go to Micro Center and buy some. I don't know.
Yeah. It's not expensive.
Yeah.
So did we find out about the power on that robot with the wheel that we're talking about 3D printing? The light up screen on the bottom right corner of my screen, back left of the robot, is that your power distribution?
Yeah, that's a little.
Your main power block? Is that your main power block right there with a little screen in it?
It's just a DC to DC converter with a
that's what I'm using too.
Yeah. It shows voltage and current, and you can, I think it might be good for maybe an amp or so. I think they always seem to overstate them, but I don't know if they have like a, forced air, trying to keep the thing cool enough so you can get its rating or something, but it seems like they're always a little overrated. Yeah, right. Looks just like that.
Yeah, that.
Well, similar to that, not identical, but yeah, those are pretty handy. It's kind of nice just to know, what current it's pulling, and
I really like it. I use it to power a lot.
Yeah, this one, it's instead of volt, it says VOL. I don't think they hooked up the T. The T never lights up. So, special price, no T.
Ray, can you just show what you're talking about just so everybody sees?
Okay.
I'm just a little lost here.
Yeah, they're just small DC to DC converters with a display.
Oh, okay.
Let's see here. Yeah. Here's one here. It's got, 2 connections for in and out, and a little display, and the 2 buttons you push up and down, and it sets the voltage.
Okay.
So it's really just a constant voltage DC to DC converter.
So it's not set to just 5. It could be, you could do 3.2 if you wanted to.
Yeah, in fact, I'm doing 3.3 on the other platform right now.
Okay.
And at least some of those
they're adjustable. They're adjustable via little potentiometers on them.
Yeah, some of them have potentiometers. Those have buttons.
Some of them also have a current limit, so you can use them as a constant current source, or at least as a not a fuse, but a kind of limit the draw from your battery.
Yep. There's another one that's this one actually has 4 buttons. I think this one I can use as a constant current source.
Can you drop a link? That one looks nice. I don't know if it's any good.
Yeah, this one will do battery charging. So it's got a little LED indicating that you're in constant current mode and whether your battery's fully charged, and can show input voltage, output voltage, and be adjustable. That was an AliExpress thing. I actually bought 5. They're all supposed to be, I think, 2 amp, and I got one that was like 12 amp. They just said keep it. Yeah, this one is the 12 amp one. I don't know if it'll actually do 12 amps, but you can see the difference in the size of the heat sinks. Oops. Much bigger. And they all have a little, LCD display. So this one's the 12 amp one. I think in Amazon, well, I can put it in the chat what the part numbers are.
Well, that brand has a number of cute little converter things like that. And I've had good luck with quite a number of them.
Yeah, and it's kind of nice just to be able to look over and say, what are the currents and voltages doing,
Someone was asking earlier about 3D printing wheels for the brushless motors.
Mm-hmm.
I'll share my screen here for a sec. So this is another robot that I was working on. I put it on the shelf for now because doing too much. But it's using a couple of those brushless motors, and this white part is 3D printed ABS, and this is what it looks like in real life. And then the black is a TPU, sort of rubbery kind of tire, and you can see the bottom of it. Take a picture of it here. So it has the Simple Fock Mini driver board and the magnetic sensor encoder board, and then this is the part of the brushless motor that doesn't turn, and the part that has the wheel on it is the part that does turn. And that's all hollow. So, like, if you look at this from this side, if I get rid of the motor, so this is what the wheel looks like. It's pretty simple. And then the tire.
Do you have a good source for those little teeny screws? Because that plate is not that big.
Amazon. So these are M2 screws.
Yeah.
If you look at these ones here are M3s, but a lot of these are M2 screws that I use on this. And if you look at the robot itself, these are.
It can only be like what?
These are M2 screws.
Long.
I think these ones are 4. They're 4 millimeters. You can get from Amazon. You can get like a kit that's got a whole pile of different sizes of M2 screws. So I bought. It comes in the little Ziploc bags, and there's a whole stack of different lengths from like I think 3 millimeters up to about 20 or something. So yeah, this center one holds there's a little 3D printed piece that slides into the wheel, which, let's see, what did I call that in the model? The magnet holder. So that actually goes into the motor, and then there's a little radial magnet, a disc magnet that sits in there, and then the encoder board sits right in front of that, and so that gives you there's actually a chip on this board that sits about a millimeter away from that magnet, and that is close enough to make that work.
Yeah.
So that's what I ended up doing for wheels and tires. Just ABS wheel and TPU tire. My plan is to, when I get back to working on this robot, probably this fall, I'm going to make a mold and pour some silicone for the tires instead of TPU. Wow. Yeah, TPU is still kind of stiff, and so it'll probably slip a fair amount on really smooth surfaces. Whereas like a silicone will be a lot softer and give you better traction.
Yeah, I didn't realize the very extensive world of rubber bands, but there are you can buy several different widths, several different diameters, several different thicknesses, and a lot of them are used to hold stalks of broccoli together. And some of the places, it's like, okay, you can buy a 5-pound bag of these things, and it's like, okay, those things are just going to rot in the bag. I'm going to use 2 or 3 of them, and all the other ones will stick to each other eventually.
Yeah,
it's amazing how the quality can vary, because some of those rubber bands can last. I've got some that have lasted decades. From the RC plane days, RC plane days in the 70s, they're still good and stretchy. And then the ones that come on the lettuce, or not the lettuce, but the celery, they're not stretchy after 3 months. They're gone.
Yeah, yeah. Anyway, I went, looked at Office Depot, Office Supply, all every place I could, and that's where I came up with the, Harbor Freight O-ring. Solution. So
yeah, that link. I mean, it's Amazon.ca, but you can probably find the same thing on Amazon.com. That's the M2 screw kit.
Oh, okay.
That I was using. That's like you get 600 M2 screws of different sizes.
Yeah.
Actually, I think that's one of them, and then there was another one that I did that was it's a cap screw. not a cap screw, a button head screw.
Yeah, one of the screws that holds the AS5400 encoder board to the back of the motor. It is very small. It's this little, like, I forget what they called it, where the head is like tapered.
Countersunk.
What's that?
Countersunk.
Yeah.
Countersunk. Yeah.
Anyway, I was taking it apart. The thing bounced on the floor and it went to Neverland. I never found it.
Yeah, I bought a whole kit of those too, in different. You can get them in like M2, M3, M4, whatever, the flathead ones. Amazon's great for stainless steel screws. They're and I tend to get the ones that are the hex driver. In the RC world, that's all everybody ever uses is the hex driver ones, and those are great.
Mm-hmm. Yeah, that's what this was. It had a little hex indentation in it. But it's on the floor somewhere.
You're pretty good at on-shape, John.
Yeah, I've been doing CAD modeling for 25 years now. And I've been doing on-shape for, almost 10 years, I think.
It seems like something that would be good to learn.
Yeah, it's fantastic. To give you another example here.
Are there decent tutorials on the thing?
Oh yeah, there's tons of tutorials.
John, didn't they also have a printing service where you could just export from the tool and have them print it and mail it to you?
They might. I don't know. I've always had a 3D printer, so I've never used anything like that. Yeah. So this is a CAD 3D model of my walking robot, and this is actually an assembly. So the parts are, you can work the parts to figure out what your clearances are and things like that. Stuff like that. So yeah, I do everything in CAD before I do anything. My Robo Magellan robot is I didn't do the whole model of the robot in this, but let's see. This is the PCB mount, the PCB that so there's a whole pile of different parts. So these are a lot of the parts that I have on my Robo Magellan robot. Like this piece is the shroud for the Raspberry Pi. So this board here sort of is the same size as a Raspberry Pi. So it's mounted on these things. And because I print everything in ABS, I can use machine screws to hold it all together. Like I actually drill and tap the ABS directly. So these are all held together with like M3, mostly M3 screws on this one, although the Raspberry Pi uses M2.5 screws. But yeah, there's all of this stuff. This whole thing should look kind of familiar. This is my GPS holder.
Hey, John.
Yeah?
Do you print the holes and then just tap them so that the holes are in the right place?
Oh, yeah. Okay. Yeah, well, I sometimes drill them out. For the M3 ones, they work pretty well because M3 is a pretty big size. Yeah. I print them at these are actually M2 holes, but like these ones here are M3 holes. So I make the hole 2.5 millimeters. And then when I print it, I can just stick I actually put my tap in a drill and just, and then back it out, come back out again. And Yeah, so if we go back to here, and
that sounds like a pretty handy technique, actually.
Oh, it's incredibly. Yeah, I don't use nuts for anything.
You strip anything out, you just print it again. Who cares? Huh?
Yeah, exactly. So you can see, all of these things are just held on with screws. Like there's M3 screws that come up through the bottom of this metal plate and then thread onto this piece, and so that is this right here. So there's actually 2 holes in the bottom of this, which are 2.5 millimeters. And so I tap those to M3, and then I've got screws coming up from the bottom to hold this whole thing in place. And these are really long screws that go from here. They actually, if you look at this from the back, I think I have a back picture of this, yeah. You can see the ends of the screws just sticking out there. These are like 35 millimeter M3 screws.
I guess with all that length, you got enough structure. This is going to be pretty strong too, right?
Oh yeah, and ABS is really strong to begin with. It's much more flexible than PLA. PLA is really hard and brittle. ABS is a lot more flexible, which is why you can tap it without overheating and stuff. So yeah, I don't use nuts. Anyway. I mean some of the RC parts, because they're metal, they use nuts, but I don't use nuts for any of my stuff. It's all just 3D printed and that. So yeah, and you can see I have screws all over the place holding the stuff together. Even nylon screws. I bought some nylon screws for the IMU so that they wouldn't interfere with the magnetometer.
So I do the same thing with PLA and PETG, and it seems to work. In fact, I don't even tap my holes. I just put the screws straight in them.
Just run it on in, huh?
Yep.
Do you use like M3 screws, or do you use the sheet metal type?
No, I use M3 mostly.
Yeah. Okay. Cool.
Bradley, you're showing something.
But you're muted.
It's my 3D printed car key. I mean, it has M2 running through. Right? Same screws, right?
All right.
Yeah.
Huh. So Bradley, what is your project?
But it's PLA plus at least.
Hey, Doug.
What project? I want to be able to take my graphics tablet. I'm a photographer. I'm on Photoshop. It goes to the computer via USB, right? I can build the mechanics and the flying part of it, but I would really like to spatially map a building, like a wall or a structure, and be able to have somebody live paint using the graphics tablet with a drone.
That's some really complex software right there.
And I don't know software, so
yeah. So building robots is a full-time thing. Like you're going to want to build the robot first. That if you can make an autonomous drone, or are you talking about a remote control one?
This would be fully autonomous. I mean,
yeah. So that's.
I mean, it's not autonomous because it's performing a role, but
right. Well, it's still autonomous. I mean,
I would use localized GPS. Localized GPS. Well, it's being controlled by the.
Yeah. So one of the things you're going to find in the real world is that nothing works the way it should. GPS is horrible. It's good if you're going hundreds. If you're going hundreds of meters, GPS isn't bad. But if you're trying to get to a specific
1
place,
centimeter.
Never going to happen. Never going to happen in the real world. GPS is
RTK.
That's not true.
Yeah. Yes, if you get RTK, then you can.
I'm talking about building RTK. Yeah.
Yeah. Then you're okay with that. And yeah, I mean, autonomous drone is a pretty serious project on its own. So I would try that first, definitely.
Done it.
Even so, high precision GPS only just works, and it will tell you it's got lock and is highly accurate when it's just totally not.
Oh, wow. Okay. And I guess the thought was to back it up with sensors, and it seems like everybody in robotics seem to be sensor folk. So it's
there's a reason for that. Sensors are life in robotics, and they don't work very well in general. Like, they work in really constrained environments, but when you go out in the real world and start using them, then you find out very quickly that you get all kinds of noise and extraneous readings and crazy stuff happening. And that's why building autonomous robots that go outdoors is really hard. You just ask any of the guys who do the autonomous races and stuff. It's
my time sensors seemed to be sensitive to motion. Like when you started moving, their depth measurement would be distorted.
Yeah, that was weird, Mike.
Yeah.
I suspect that's more of a timing lag thing with ROS or something like that, rather than the actual sensors, because those sensors run, I don't know how fast you're polling them, but they run at like 30 or 50 hertz or whatever, and you should be able to get real-time measurements from them without any problems. So it might be a ROS thing.
Yeah, I noticed on the corner it said the frame rate was 28, FPS, frames per second. So that's okay. I think
that was a blob detection. The 8x8 sensors I have run at 10 hertz.
Oh, is it 10? Yeah. I guess you can get some effects like that. I mean, Chris, you showed that where, if you rotate it, it's like the measurements seem to get really twisted and lagged substantially from.
Yeah.
I suspect it depends on what kind of filtering they're doing too, because if you're doing filtering based on historical measurements and stuff, then you end up inducing lag in the sensor readings. So
I had no filtering, and I was looking at the raw data from the sensors, and they just had longer depth. When I was moving forward. It sort of freaked me out.
Redshift. Oh, it's Redshift.
That's what I thought.
Well, I wonder. It'd be really interesting, Mike, to see if we can understand that more, because these time of flight sensors, they actually are. They don't work like you'd think they would, like send out a pulse and measure the time till it comes back.
Right.
I mean, they indirectly do that, but really over very many pulses, and they're like splitting them into buckets, and they bucketize the return pulses to try and get the accuracy down into the picosecond range, which you need for that kind of accuracy. And I wonder if there's some kind of lag involved in that bucketizing process.
Maybe, because there's a lot of signal processing on the sensor chip itself.
Yeah. I mean, those sensors you're using are pretty complex with the 8x8. I mean, that's 64 buckets that it's filling. So it's hard to say that. I've never used any of those. I've only ever used the single beam ones. They have the whole region of interest thing that you can play with, but they definitely don't have the whole 8x8 grid kind of thing.
The spans,
yeah. So it's I suspect it would be interesting to build a little linear track that you can control and do some actual testing with it and see what kind of latency you get with that versus just the single beam ones and see if that makes any difference.
And Mike's thinking, yeah, it would be interesting, but I've got a competition coming up. To make work.
Yeah.
Well, plus it makes me think this discussion. You know how with cameras, when they smear moving images because of the sampling happening in different places across the image over different times. I see smile from Bradley.
The scanning.
The scan, the kind of smear. I wonder if that kind of smear is going on with these time of flight, especially the arrays, in the way that they sample over periods of time and space.
Yeah. What did you say your update was, Mike? Update rate?
It's 10 hertz, and it's sort of averaging for many milliseconds.
Okay. 10 hertz, yeah.
But that's your readout of the sensor. The sensor itself inside is making multiple measurements for every sample that you get.
Yeah. It's real busy, right?
I figured there's got to be some smearing just within the sampling that your sensor's doing, even before it gives you the data that then you go just average.
Right.
So,
can you look at like the load? Can you look at the load rating?
Samples,
like, Can you look at the Can you look at the load rating? Like how many samples it's having to do?
Oh,
it's an API.
I know what your refresh rate is, and like, why can't you have like he's got the PID for the motor? Why couldn't you have the PID for, let's say, the buildup in the sensor lag? Same thing where your derogative is knocking it out at every whatever frame. You know what I mean?
Yeah, I've never heard of that being applied to that, but it's a possibility.
Possible.
Well, you can predict. You can. I think you're talking about. I forget the names of the filters, but there's ways that they can monitor the incoming signal and predict where it's going to be. Right. So. So those kinds of those are just higher order filters. This averaging is just a second order filter, but I think you're talking about third or fourth order filters, which are
like in the drones we use it in RPM filtering, like the telemetry feedback from the motors.
Yeah,
through the ESC feeds it back, and we can see now in chunks based off of like whatever harmonic it's running off of on the feedback.
Yeah,
based on how many motor poles, etc. It's a whole new. It is a third level of filtering.
It's another
like notch. What we call it, notch filtering.
Yeah, they're more complex filters. Well, we're talking about here. So, Bradley, these time of flight sensors.
What are they?
Well, so when I grew up, like in the 80s, and I worked in the defense industry, the time of flight sensor meant that we had a pulsed laser for these military ground vehicles or air, and we would charge a pulse forming network to 20 kV, and then we would dump that in 80 nanoseconds across this highly pure gas, CO2-based gas with mirrors, no smoke but mirrors, and then out would go megawatts of optical energy that was like 100 nanoseconds wide. And then that would fly through the air. Doesn't matter if there's dust and crap in the battlefield. It would go out 10 kilometers, come back. And in that time, the circuit that I built had a stopwatch, so it would be able to tell you how far the light traveled and how far was the target. Well, that's what it was in the 80s. But now these days, if you look at like modern phones, if you've ever noticed they're on speakerphone, but you put them to the ear and the volume goes down, well, how does that happen? It happens because
it has a light sensor,
have a time of flight sensor that knows when it's getting close to your ear and that it better turn down the volume to protect your hearing. So there's actually there's lasers, right? There's lasers in there, and they're spitting out photons. And if you read, like we did this a couple years ago, Dave Ackley and I, we were looking at, he found a data sheet for STS Micro for some of these time of flight sensors, and they talked about how they work. And that's where you mentioned patents at the start of the call. That's where the patents are in there galore, because I don't know how many, like 50 or 80 patents in these little sensors, and they claim that they can count individual photons, but in reality they have buckets that count many photons, and then they do fancy schmancy math. But and then they're not, so for oscillators and silicon to count time that quickly. So like when I did the lasers, I could use a 30 megahertz clock, and I could tell you how far a target was. With a 30 megahertz clock, I could tell you how far a target was in 5 kilometer or 5 meter increments, 5 or 10 meter increments. Okay. but 5 or 10 meters doesn't work close to your ear. So these little sensors can get you down to the millimeter range. But to do that, they're using a different thing. They're not they're measuring, I don't know, phase shifts and frequency or something of pulse bursts. So it's a pretty complicated algorithm that they have. And but anyhow, so that's what's going on inside of these little chips in our phones and our robots. And then we just sample them at like 50 or 100 hertz, whatever we get their answer at. But what's going on inside the chip is a black box. We just take it as magic and accept it. But I'm
I guess he wants you to know.
Like we've seen in many of these sensors, right? If you don't if you forget about all this magic that happens in the black box, that's where maybe some of the smearing can occur. It's happening inside before you even get the data.
Yeah, the data
I didn't
sheet
think
for that
Arviz was that fast.
My sensor is right there.
That's your time of flight sensor?
Right, at 8 by 8. Mm-hmm.
Yeah, the
and it's 8 by 8, yeah. So the ones that our ears are single, one by one.
Yeah, so the data sheet says you can run those 8 by 8s at 60 hertz. Are you using
4 by 4. Only when you dumb it down to 4 by 4.
Yeah. Are you using I2C or SPI?
I2C.
Yeah. Okay.
It's just waiting until the measurement's done. It doesn't wait, but it polls it. It says, "Oh, measurements are all done on all 3 sensors. Grab them all and send them to the Pi." Yeah.
Yeah.
So it's just waiting for the sensors to be finished.
Are you running in fast mode, like 400 kilohertz, or
I think I'm megahertz.
Oh, okay. Yeah. They do up to megahertz. So.
Yeah, but once I grab the data out of it, it starts all over. But yeah, right. Yeah, it's pretty fast. There's not a lot of overhead I use the Raspberry Pico. Yeah. Yeah. But and I'm writing it in C, so it's fast. Yeah. But all the code in the Raspberry Pi is Python. But
how are you sending that data to the Pi over a serial port?
USB serial.
At what baud rate?
USB serial. It's just super. I run it at 115, but I could probably run it at 1 meg. But it's USB serial. So it runs as fast.
Yeah. But Mike did something that really indicates that it's in the sensor. He said that when the robot moves forward, the target moves further away.
Right.
So if it was caused by lagging in like comms links or latency in processing, you would see the target move forward because your measurement is delayed. The fact that the target moves further away indicates that it must be happening in the sensor.
I think so. But my practical solution is to wait till the robot's in a paused, stopped position and then make the measurements.
How long does it take it to settle in, Mike?
Oh, it's instant.
Okay.
Once you stop,
once the robot stops, it's
it's good.
That's interesting because I did a single beam LiDAR scan on my walker. I've got 5 of those single beam sensors, and I use 3 of them and rotate the head 90 degrees, and I get, I think, something like 1,000 measurements inside, half a second or something, or maybe a second when I'm doing that scan, and end up with something that looks like one of those rotating LiDARs over 270 degrees. So it's moving while it's not moving linearly, but it's rotating while it's doing
it. Right.
I don't know if that's any different.
And also I try to speed up my robot, and I'm using the time of flight sensors for obstacle avoidance. And if I run it a 1/4 of a meter per second, they're pretty good. But if I run it a 1/2 a meter per second, then they're like double error.
Maybe when you're moving fast, you should switch down to the 4x4 mode on the sensors when you're using them as obstacle detection, and then switch back to the full mode when you're looking for cans.
Yeah, but before he does that, I have a homework assignment for you, Mike. Here's the homework assignment.
Uh-oh.
Since you found this super cool effect and you have an audience full of really enthralled people who really want the answer, so your challenge, should you choose to accept it, is a step function response. Start at one end of your course, right? Turn your sensor on as fast as you want to run it. Who cares? I don't know, 8x8, 4x4, whatever. Just pick one, the one that gives you trouble. Start at one end of the course, right? And then move the robot as fast as you can and monitor the distance of the wall, and then stop the robot before it crashes. But so the head doesn't pop off. But do this, and then move it really fast and stop really fast, and then plot the distance, which you can measure pretty accurately from your odometers. And knowing the distance from the odometer and the wheels, you know the distance to the wall. So plot the distance to the wall that you know that you got against the reported distance by these sensors. And then let's look at the step function response. That's what I want to see.
Yeah.
Yeah. And I'd be really interested to see the values without involving ROS too.
Yeah.
Plot them with the Pico directly.
Yeah.
Because I suspect, given that you're sending this data up to the Pi over 115.2 link in serial, you're going to end up with some latency with that too.
So before you start designing solutions, I would start to understand what in the world do you have, and that you need step function response.
I'll write it down.
I'm good at homework, so or giving it out anyhow. I wrote it down. I gave homework to somebody else, but they left. So okay, we'll come back to them next week.
Okay, are we running out of topics to talk about? Anyone have anything they want to raise? Zach, I saw you joined.
Go ahead.
No. I was going to ask if you.
I wanted to know that RoboDog has played Phoenix and risen from the ashes again. I replaced the Arduino, and that fixed my problem. And I think it will be go for April the 6th. And I've built this fastener here, which is what the hooks I have on the bottom will hook onto on my back, and this will hang over my shoulders and support the 20 pounds. And so that's good. I'm making progress there. And thanks, Paul. I went and got one of these. I haven't opened the box yet. It has to be after April.
Don't drop it.
I won't.
Don't drop it or its head will break off.
I missed something in the early part of this conversation?
I don't know if you were there when this sad event happened.
Oh, no. I was in my astronomy meeting.
Yeah, the server broke right off.
I bought some more of this film to put over my telescope. So I was in my astronomy meeting. We were talking about the upcoming eclipse. And I only just got back about 9:30 to see what was going on here. So that's all I had. I just wanted to say that RoboDog V1 was back alive again and will make its debut. I unfortunately will not be able to come to the in-person meeting. I was going to show him off, but I have family coming in from out of town and they take priority.
Next time. Just don't drop RoboDog in his head.
I'm going to try not to. He's got to hold on to this. He's got some really strong hooks.
Hey, Doug. So when you go to your conference and you got the whole uniform on or the whole costume on and the dog's walking, can you get some video so you can show us?
I will try to get the wife who's good at taking pictures to take some video and some pictures, and I will demonstrate them.
Okay, that'd be great. Love to see it.
A lot of the behaviors that Paul showed in his little dog is what I wanted my dog to do, and now I've settled with, can I just get the thing to go forward, backwards, and turn?
Well, maybe, Doug, maybe you could swap out the underneath, the specifics of PiDog's servos and plug it in and run the same software or similar software.
The little servos probably won't handle the weight. That's 20 pounds. That's why it wasn't able to sit up and get down and everything. It just couldn't handle the weight. Interestingly enough, as long as we're just chatting, when I get this puppy done, V2, I'm planning on, he's such a slow-looking walker, watching him walk at your screen. I want him to step onto a platform that has wheels, and the wheels can drive him around like a sled. We'll see how that works out.
Oh, but did you see him trotting, like when I showed him trotting last week? Because he goes pretty fast when he trots.
Oh, no, I don't. I think I missed that. I had to leave the room a couple of times. I probably missed it.
Yeah, no, he trots along with good. He won't trot on carpet, but he trots pretty well on a hard surface.
Well, cool. I'm gonna be busy putting him together next month after I finish this April 6th thing.
It's a fun project, fun thing to assemble.
And that's all I had.
Hey, anyone else got anything?
Hey, when's you want to see moderately fast? Sorry, go ahead.
Yeah, moderately fast.
I'm looking for something that can walk the same speed I do.
No.
Jack, what was the question?
I was wondering when the meeting was. I think I heard something about an in-person meeting.
Yeah, October 23rd. I mean, no, excuse me. March 23rd. March 23rd at 10 a.m. at Makerspace.
I don't know that I'm going to make it there.
This coming Saturday.
Yeah.
Week from Saturday, right? Oh.
And I don't know if you were here when I announced.
I didn't see this.
Yeah, this Saturday.
Right.
Are you on DPRG list?
I thought I was. Maybe I haven't.
If you can message me your or send me an email somehow, I can add you to the list of people not reached by DPRG list, and then you'll. I'm copying everything over manually till we get transitioned over to the new listserv. So.
All right. Thank you.
I'll put a link in the.
Whoop. Hey, Brandon, you don't want to do that, but oh man, yeah.
What's the issue, Doug? Help me understand why you recommend. I mean, you said you'd tried removing, and it was really hard to remove email addresses. But what is the actual key issue here?
Well, it's probably not too much if it's on there just for a second, but you don't. What the problem is that it goes all over the world. And it's like publishing your email to everybody in the world. So
the world and all the spammers have my email. So why would I?
And Google's really good at getting rid of spam. So
it really is pretty good.
But it's just saying, right? It's a policy thing.
It makes more. What I'm saying is, I don't want people to get.
I can read. Oh, sorry.
I don't want people getting spam based off of the list. That's, I guess, what I'm trying to say. For example, we've had cases where people put phone numbers in, and that's even worse. I don't want that to happen.
So maybe a way to express it is if you put your email address up, you take responsibility for someone spamming you on that basis.
Okay. If Carl or whoever is recording without showing chat, it's not a big deal.
Yeah, and that's what I standardly do. So it might come up it comes up with a notification for seconds.
Yeah, that's probably all right.
But then when we copy the text chat and you put that in the site, we usually strip the emails out.
Right.
Okay, so do you want me to put my email address in, and then you can send me an email, and I'll add you to the list?
Mm-hmm.
7 Photons. What's your first name? 7 Photons.
Oh, I'm sorry, Jack.
Jack. I'm sorry, I knew that. Do you want me to put my email address in the chat, and you can send me your email, or just send it to president@dprg.org. There you go. Okay. Yeah. That's public, and then I'll get it and I'll add you to the list of people that I copy messages to.
All right, thank you. I appreciate it.
But anyway, in the bottom line, we got a talk coming up on Saturday by a VP of Kabam Robotics, which manufactures 2 security robots, and he's going to describe the robots and talk about the whole system and everything, and offer to take us on a tour of their experience center, which I think should be really cool because we'll actually be able to see the robots in person, so to speak, and whatever kind of back end system they've got that handles monitoring and alerting.
So Jack, plus they're hiring.
Oh, they are? Oh, all right.
They're hiring. They're going to be hiring in the DFW area, as they establish a presence here.
And will the tour be on a different day?
Yeah, it'll be on a different day. We'll talk about that when at the meeting.
All right, thank you.
All right. Mickey Dean, you asked if we have a meetup link for the March 23rd event. Yes, it's on the website. It just got put there today. So if you go back and look at the meeting agenda at the meeting list, you'll find the dial-up meeting, the Google Meet details.
And I just put it in chat 5 minutes ago. So the 23rd March, yeah.
Okay.
So Jack, did your coffee servers start working, or did you finish it?
Actually, right now, I've been kind of working on the app. I don't really have anything to show with that yet, but I'll show you all when I have something to present.
Oh, great.
With that.
Mm-hmm.
Okay. Anything else?
You guys want to see a moderately fast walking robot?
Oh, yeah.
I like your 4-legged robot. That's very cool.
It's, oops. I don't think it's quite as fast as a person walks, but it's getting there. It gets kind of funky on carpet sometimes, too. Yeah, it's doing real-time inverse kinematics and obstacle, not really obstacle avoidance, more just trying not to run into things.
And Doug Parody, the PiDog doesn't do that sort of look for, or at least the apps that they ship it with don't do that look for open space and head towards it kind of behavior, do they? That you know of?
Not that I know of. Oh, I have, it's only got one sensor that I know of. That's the ultrasonic. And on my particular version, for some reason, I can't get the ultrasonic to work. So I haven't really explored that.
Okay.
There's no reason why you can't, because you can move the head side to side.
Right. And when it's on patrol mode, it moves its head side to side. So you'd think you just have to read it's emitting the distances to the terminal. So I would think a version of that program might do what you want.
Yeah.
Okay. Well, if no one has anything else, I suggest we call it a night.
Mm-hmm.
Sound good?
All right.
All right. Good talking to you guys. Always fun. See you next week.
Good night.